In this last video, we're going to talk about how to determine sample size now for a quantitative variable. So first, as a reminder, we did this when we were back in Module 4 for a categorical variable. We had this sample size formula, but looking at it, it had p hat in it, which is a sample proportion. And again, remember, proportions are only for categorical variables. So since we're now working with a quantitative variable, we're going to need a different formula to be working with. So as a reminder, sample size plays a big role in how wide our interval is. And one of the reasons that we focus on width is because we generally like narrower intervals. And the reason that we like them is that they are generally more informative. So that is, it narrows down a lot more of what the actual value is. Even if I don't like the values, it's more informative, right? If I told you the population mean exam score is somewhere between a 10% and a 90%, that's not very helpful. But if instead I can say that I believe it's between a 65% and a 72%, again, even though you might not like those numbers, it's a much narrower idea, so you really have a much better clue of what's going on. So what we need to have happen in order to find sample size is there's a few different things that we need to know. One of the things that we need to know is how confident we are wanting to be. And that hopefully seems pretty reasonable. So things we need. How confident do you want to be? Do you want to be 95% confident? Do you want to be 99% confident? So I need to know that. Another thing I need to know is a margin of error. Now at first that might seem unreasonable for me to know, but I really just need to know, well, how close do you want to be? Are you good with being within 5% of the actual exam score, or do you need to be within 2? So how far off are you willing to be? So I want to know that. So both of those seem pretty reasonable. The last thing that's not as reasonable that I need to know is sigma, our population standard deviation. Now, the reason why I say that's much more unreasonable for us to know here is because we sort of started this module by talking about we don't generally know sigma, our population standard deviation. So generally what we have instead of sigma is a lot of times we end up using a sample standard deviation if we don't have anything for the population one. So these notes that I wanted to list here is that we must have an idea for sigma. There's not a here's the number to plug in if I don't have anything else. I have to have something. So again, we could use our sample standard deviation. The other note we're going to talk about will be after we actually look at the formula. So our sample size needs to be at least as big as z. Z is going to be based upon how confident we want to be. So like again, like that 95% versus 99% times that standard deviation over the margin of error all squared. Now it might also seem a little odd here that I'm using z, because again we've been using t a lot in this module instead. So why am I using z? Well, let's remember where we found t when we did a confidence interval. We needed to know how confident we wanted to be, which we have here as well. But then I also had to know something called degrees of freedom. Now degrees of freedom for our confidence interval that we did was our sample size minus 1. That's where the problem is. Here I'm actually trying to figure out, well, how big of a sample do I need? So I don't know my sample size. So I can't figure out what degrees of freedom that I want to use. So what I know is that z and t are pretty similar. So if I use z, it is not going to be that different. So then that note for that part is if we end up getting a sample of at least 60 when we're done, the z versus t is not a big deal. If you end up getting a smaller sample size, that generally means it's much more of a concern for us. All right, this seems like a lot, but let's see if when we apply it to a couple problems, if it makes sense. So suppose that Pizza Hut wants to estimate the mean number of pizzas it sells each day. Now they might care for this, making sure they have enough dough or make sure that they have enough other ingredients and stuff like that so that they know how many pizzas they sell each day. So they believe this varies with a standard deviation of 65 pizzas. So we're given our sigma. How many days should be sampled to be sure they're within 16 pizzas with 99% confidence? So those are our three key things. I know my sigma. I know my margin of error. That's how close I need to be. So I need to be within 16 pizzas. Finally, this 99% is going to help me find my z, but it's not going to give me, this is not the number itself. So if I look up the 99% confidence for my z, we're going to get 2.576 using our table here. Or if you use your z table, you'd only get 2 decimals, like a 2.57 or a 2.58, which would be perfectly fine as well. So then from there, I can just plug my numbers into my formula. My z was my 2.576, my sigma was 65, and my margin of error was 16. Now doing the math, we get about 109.5. Remember, we can't only sample part of a day, so here we always want to round up, because if we have to sample part of that day, we're going to sample the whole day. So we need to sample at least 110 days. All right, after one example, it might be good to pause the video here and try to work the next example to see if we're feeling good about where I'm getting those numbers before you check the answer. All right, so for example 4, hopefully you had the standard deviation as $4,500. The margin of error is the $1,000, how close they needed to be. And the z was based upon the 95% confidence. I got 1.96 from my table here. Again, could also use the z table to get that value. So that's where all my numbers came from. Then plugging the numbers in. It's common for students to forget about the square, just as a reminder. That's easy to miss up there. So you got around 77.8. And again, it doesn't matter what this last decimal point here is, I'm always going to round up. So if I got a sample part of the week, even if it was 0.2 of the weeks, I'm going to round up. That's also why I write this as a greater than or equal to, kind of tell me I can't go smaller, I have to go bigger. So we should have got 78 weeks. Now that's where our part of the problem is going to end. How someone would use that is then to ask themselves, well, can I do that? So 78 weeks is about 1.5 years worth of data. I would assume that Old Navy is smart and has kept records of their sales. And so they should be able to go back and get maybe the last 1.5 years of data and use that to help them calculate it. However, if they were starting a brand new study, hadn't been keeping records, waiting 1.5 years to get your answer is probably going to be too long of a time. So they would want to make sure, can I actually do this? If so, great, let's do it. If not, let's see where I need to be willing to make some changes. So if I couldn't do this big of a sample and I needed to make it smaller, the two things that I could really change are my confidence, so I could be less confident if I wanted my number to get smaller, or I could increase my margin of error, be willing to be off by more. So again, how we're going to use it is just for the calculation, but how people would really use that is, can I do this? If so, great. If not, where am I going to be willing to make some compromises?